Hello, grade 8. Welcome to lesson 8. And we are still busy with equations. But this time around, we're going to add a little thing to our equations. And we are moving to what we call exponential equations. I'm sure you remember what exponents are. Let me remind you what exponents are quickly. Now, exponent is a number that has a base and a power. A number that has a base and a power. So we talk about exponents. We say A and B, where A is the base and B is the power. And the whole thing is called exponent. So please take note, we are going to be working with exponent, and we have different laws of exponent. There are basically 4 laws. But before we go on to that, let's see. If I have a number here, can I write that number as an exponent? This is going to be very, very important for us. Okay, so for example, if I have a 1, can I write 1 as an exponent? Yes, there's a general rule that any number to the power of 0 is 1. Let me show you. I know we are not using calculators, but if I get a calculator and say 5 to the power of 0, check your answer, 1. So any number to the power of 0, check, 900 to the power of 0, 1. Any number to the power of 0 will give us 1. So let's take note of that. Now, can I write 2 as an exponent? Yes, 2 to the power of 1, which means just 2 by itself. Now let's look at something. Can I write 4 as an exponent? It is 2 to the power of 2, which is saying 2 times 2, right? Exponent. If I have 8, can I write it as an exponent? Yes. I need to multiply 2. How many times? 3 times. Take note of that. So the number of times here is what goes on top here. How many times am I multiplying 2? 2 times. Oh, beautiful. If I have 16, it's basically 2 to the power of 4, which is 2 times 2 times 2 times 2. You can see how many 2's am I using? I'm using 4 2's. Let's look at a few more numbers before we go into equations. Let's look at a few more numbers. Oh, I could also write 16 as 4 to the power of 2, which is 4 times 4. Do you see? How many 4's? 2. Okay, look at, I could have 32, if I want to continue, is 2 to the power of 5. Because it's 2 times 2, which is 4, times 2, which is 8, times 2, which is 16, and times 2, which is 32. Beautiful. So if I start with 3, it's just 1 3. So 3 in just one place. If I have a 9, it will be 3 to the power 2, which is 3 times 3. Can you see how many 3's do I have? 2 3's. If I have 27, it's 3 to the power 3. You see, not just 3 times 3. It is 3 in 3 places. I hope that makes sense. Now, if I have 81, that would be 3 to the power of 4, which is 3 times 3 times 3, which is now 27 times 3. Beautiful. And I can also group this as 9 times 9, which then gives me what? 9. How many 9's? 9 to the power of 2. And that will still give me 81. So that is changing your number into exponent. Not all numbers can be broken down. We use prime numbers. Okay. All right. I'm sure you know your prime numbers. Please, it's important to know those basic numbers. You've got to know your 2 to the power 1, 2 to the power 2. At least you've got to know up to, let's say, okay, look, this is what I'm saying. You've got to know this. 2 to the power 1 or 2 to the power 0 is, 2 to the power 0 is 1. Any number to the power 0 is 1. 2 to the power 1, 2. 2 to the power 2. You must know this. 2 to the power 3, 8. 2 to the power 4, 16. 2 to the power 5, 32. 2 to the power 6, you must know it's 64. 2 to the power 7, 128. 2 to the power 8, 256. 2 to the power 9. Just practice these things. 512. And 2 to the power 10 is 1024. You must know that. Same thing with 3 to the power 0 is 1. 3 to the power 1 is 3. 3 to the power 2 is 9. 3 to the power 3 is 27. 3 to the power 4 is 81. 3 to the power 5 is 243. At least if you can know this, you're fine for threes. Okay, and then you just do the practice to the 4 and the 5. You must know a few of those at least. Please go and learn 4 to the power 0 to 4 to the power 5. Go and learn 5 to the power 0 to 5 to the power 5. Please learn those things. Okay, now how do we bring exponents into equations? Before I do that, just remind us of the laws of exponent. Number 1, multiplying with the same base. Multiplying with same base. What do? Keep the base, and this is what we're going to use a lot, and add the exponent. So I'm just going to remind you of this law, and then we move to our equations. For example, a to the power m times a to the power n, we keep the base and we add the exponent. This is why x times x, remember it's a 1 here, it's a 1 here. 1 plus 1 would give us 2, x to the power 2. So x to the power 3 times x to the power 2 will be x to the power 3 plus 2, which is 5. I'm building and reminding you of the things that we've done. 2x to the power 2 times 3x to the power times 3x. What would that be? We multiply the numbers. 2 times 3 would give us 6. Then we deal with the variable. There's a 1 here, remember? 2 plus 1 would give us 3. Okay. All right. Having said that, because that's the one we're going to use mostly for this session, this law, we can then walk to how to solve exponents. So in solving this, we are actually looking for the value of the power. We are going to be looking for the value of the power. I'm just waiting for you to finish writing. We're going to be looking for the value of the power, because my power is going to be a variable. Are we done? Okay. All right. Or you could pause. Now we are going to be, aim is to find the value of the power variable. And I'm going to give you steps that I would follow myself. Steps. Number 1. Isolate the exponent. You know what I mean by exponent right now? A base with a power. Something like that. Or simplify if possible. I'll show you if possible. Number 2, make the left hand side and the right hand side. We spoke about LHS and RHS a while ago, lesson 1. Make the left hand side and right have the same base. This is very, very key. And number 3, if the bases are equal on both sides, equate the exponent or equate the powers and solve. Don't worry, I'll take you through the 3 steps. I will take you through the 3 steps slowly. Take you through the 3 steps very, very slowly. I'm going to look at about 10 examples. So I'm going to need you to work with me. So you would see in our first example that we do not know what x is. But you know in your head, right? But remember, we said mathematically we're not marking your head. We're marking what you can pull down from your head. Because we're going to have your book, not your head, to mark. So we have 2 to the power x equals to 4. Oh, let me put the instruction. Find the value of the variables, because I'm going to change from x to y to a to b. Okay, so you would notice that what is missing is actually the exponent. All right, let's follow the rules. Step 1, isolate the exponent. What I mean is let the exponent be on one side and the other number on one side. So for this one, rule number 1 is already done. Okay, rule number 2, make the left-hand side and the right-hand side have the same base. Okay, what's the base on the left-hand side? It's a 2. Can I make 4, or can I write 4 as a base of 2? Yes. What is 4? 2 to the power of 2. I have made the left-hand side base equal to the right-hand side base. Step number 3. If the bases are equal on both sides, equate the powers and solve. Oh, do you see that I have a base 2 on both sides? I can then equate the powers. X is equal to 2. Makes sense, because 2 to the power 2 is 4. And we're done. Easy peasy maths. All right, please write that quickly while I do a few more. Remember, we're showing all the steps that we need to do. Look at this one. Then we're going to take it further in our third example. Can I write 81? Yes. It's 3 to the power what? 4. So if my bases are equal, what do? I equate the powers. X is 4. Please write that quickly. Number 3. Now we're beginning with some crazy stuff. Number 3. We're going to follow the same principle. All right. So this 2 has a power of x plus 1. The x plus 1 is actually a power there. Now, can I write 16? So rule number 1 is fine already. Step number 2. Can I write 16 as a base of 2? Yes. 16 is 2 to the power 4. Oh, since the bases are now equal, I can equate the exponent. X plus 1. Now we go back to solving. The 1 here is adding. When it goes to the other side, it has to be reversed. And x is 3. Beautiful. Everything is coming together. Everything is just in place now. Everything is coming together. Please write that. We look at example number 4. Okay, I'm sure you tried. 3 to the power x minus 2. Now this can be written as 3 to the power 2. So x minus 2 equals to 2. The negative 2 then goes over and becomes a positive. X equals to 4. Lovely. Please write that. We have a few more. We good? Okay, let's do a few more questions. Number 5. Look at this one. 2. I'm going to put a dot there, which means multiplication. Lovely. Now, I want you to look at this because I'm going to do this in 2 ways, and you need to learn both of them. Okay. I'm going to do them in 2 ways. So watch, one on the left and one on the right. Now, 2 multiplied by, that dot is a multiplication. Now, our rule number 1 says we should isolate. That is, keep these on the left hand side. And you remember the rules of the rules of equation. I need to get rid of that 2 here, which is multiplying. If I get rid of that 2, what will happen? It will go to the right hand side and divide. That's the reverse. So 2 to the power x is equal to 16. Oh, can I write 16 as a base of 2? Lovely. 2 to the power 4. So what is x? Since the bases are the same, I equate the exponent. Or equate the powers rather. Equate the powers. X equals to 4. Interesting. I'll do the second option. And as a mathematician that you are, you should know both options. Now, this is using rule number 1 of exponents. Do you notice that that's a 2 to the power 1? And if I am multiplying with the same base, what do? We can keep the base and add the exponent. That was why I revised that with you. Oh, by the way, okay, let's leave it like that. Take it step by step. So I have used the rule of exponents. Now, I can write my 32 as 2 to the power 5. Oh, so these now have the same base. What do? Equate the exponents. Now, do you notice that the 1 on the side is actually an addition, which when changes side would become what? Reversed, and it's subtraction. 5 minus 1, x equals to 4. Don't worry, I'm going to do another one for you. I'm going to do another one for you. Please write that quickly. I'll do number 6. Let me write number 6 while you're busy. Okay, let me keep, before I start changing stuff, let's do this. Okay. Again, please, before you do this, you've got to watch and make sure that they're of the same base. I'm going to do one without the same base right now. Check that. That's basically saying 3 times 3 to the power x. Okay, let's isolate this. We want to keep this here. The 3 is multiplying. It will then divide. So 3 to the power x will be what? 9. 81 divided by 3. Sorry, 27. My head was already trying to get an answer. 27. 27 times 3 is 81. Now, can I write that as a base and an exponent? Lovely. So since the bases are the same, the powers would be the same. X equals to 3. Okay. Let's do it in another way. Just hold on writing. There's a 1 there. Because they have the same base, I can keep the base and add if I'm multiplying the exponent. Lovely. Now 81 can be written as 3 to the power 4. That's why I said it's important to know those numbers. Since the bases are equal, I can also equate the powers. Now the 1 here is adding. It will come here and subtract, and x will be equal to 3. Beautiful. Please let's write that as quickly as possible. Maths is just fun. Fun, fun, fun. Let's look at this one. It's looking interesting. 5 to the power of x multiplied by 5 is that. All right, do you notice that we have the same base on the left-hand side and we're multiplying? Beautiful. Okay, so the first method was to get rid of the other 5, which is multiplying, and 5 divided by 5. So 5 to the power x equals to 1. Can I get a value for x here? Question is, can I write 1 as a base of 5? Let's go back. Can I write 1 as a base of 5? Yes. Any number to the power of 0. Do you guys remember? Any number can be written to the power of 0, and that number should be equal to 1. Oh, and our rule says make sure that the bases are the same on both sides, which means I would come here and say 5 to the power x. Now this can be written as 5 to the power 0. I'm not just writing any number. I am keeping a base of 5 because I want them to have the same bases. Now since the bases are equal, the powers are the same. X equals to 0. And that's method 1. Or a learner sees that, okay, since I have the same base, I could actually keep one base and add the exponent. But if I write a 5, it's the same thing as saying 5 to the power of 1. So x plus 1 equals to 1. The 1 here is adding. It goes on the other side and becomes a subtraction. And x will be equal to 0. So it's important to quickly learn all of this. A few more examples. I'm going to start variating them again. I'm going to variate the examples. So this is example number 7. Okay. So you would notice I'm repeating. So I did the same type of questions here. For question 1 and 2, I did the same type of question. For question 3 and 4, I did the same type of question. 5, 6, 7, did the same type of question for emphasis. Now, question number 8, I'm going to change the question now. Same, not really change, okay? Now, look at this one. The first thing I realize is the 2 and the 3 are different numbers. So I don't have a choice here. I cannot multiply. It's wrong to then do this. I don't even know what to write. It's wrong. Why? They don't have the same base. I'll have to get rid of the 2. And what is my 2 doing here? My 2 is multiplying. When it is reversed, what's going to happen? It will divide. So 3 to the power x, 18 divided by 2 is 9. Oh, now I can write 9 as 3 to the power 2. And therefore, since the bases are the same, I can equate the powers. X equals to 2. So I'm going to give you quite a number of activities. You just need to come back to the examples and follow through. Please write down number 8. Look at this. So clearly the 3 and the 5 are not of the same base. I cannot even use the laws of exponent. The only thing is to get rid of the 5, which is multiplying, comes over to the right hand side and divides. So 3 to the power x is 3. Lovely. But this is the same thing as 3 to the power 1. So x is equal to 1. Since the bases are the same, we can equate the powers. I'm doing the same type of activity again for you. Number 10. I just want to write number 11 quickly. All right. Now, if you look at number 10, I have a 2 and a 3 different bases. I cannot use the laws of exponents. So the only rule is to say 54, the 2 comes over and divides. 3 to the power x is 27. Now I can write these as 3 to the power of 3. Since the bases are the same, I'll equate my powers. X equals to 3. Lovely. Lovely. And we have this one. Okay, this I can do in 2 ways, but let's maintain. Now, 2 and 4 are not the same, so I can write this as 4 to the power x, 32 over 2. 4 to the power x. What is the half of 32? 16. Can I write this? Yes, I can. 4 to the power 2. Since the bases are the same, the powers are going to be the same. Beautiful there. Beautiful. Beautiful. I want to do something here. I want to do something here with this particular question. Write as quickly as possible. Now look at something here, something nice. What if I decide to write the 4 as a base of 2? Okay, let me do this first. Let's do it together. So 2 times 4 is 2 to the power 2, right? But there's an x there, so I'll have to keep the x. Oh, okay. Did you see what I did? Look at it. My 2 is still there, but 4, I realize that I can write 4 as 2 to the power 2. Oh, beautiful. Now, do you notice that this is 2 to the power 1? And since they have the same base, I can actually add. Keep the base and add. And 2 to 32 is 2 to the power 5. Interesting maths. So what do I have? 1 plus 2x, since they already have the same base. Are we good? Now the 1, we go back to where we started from. The 1 is adding. It goes over and becomes 5 minus 1. So 2 to the power x equals to 4. What is the value of x? I'm just going to squeeze it here. The x and the 2 are multiplying, so 4 over 2, and x is equal to 2. Do you see it gives us the same answer? I'm going to do something like this again. I will be doing something like this again. Okay. So I have about 4 more, just one more slide of activities, of examples to do. And then I'll give you quite a number of questions to run with. Number 12, look at this. What if I have this 4 to the power x? Now, do you notice that I cannot write 32 as a base of 4? But I can write both numbers on the left and the right as bases of 2. My 4 can be 2 to the power 2, right? But I have an x there. Lovely. And my 32 can be written as 2 to the power 5. Since the bases are equal, I'll equate the exponent. Just trust the process. Now, 2 is multiplying x on the left. If it goes to the right, it will divide. And I cannot simplify further. I'm going to leave my answer like that. Okay, do you see we're moving to another type of flavor of question? I'm going to give you another one. Eight to the power of x is 4. I cannot write 4 as a base of 8. That's just crazy. Okay, but can I write both of them as a base of 2? Always go to the smallest numbers. They're always very helpful. 8 can be written as 2 to the power 3, but I have x there. Oh, and this can be written as 2 to the power 2. Beautiful. Both of them now have the base of 2, so equate the powers. What is happening? The 3 is multiplying the x. Oh, so it's going to divide. Case closed. Interesting maths. Number 14. I'm going to do something similar. Let's do something similar. Hope we're done writing. Let's look at this one. I cannot write them as the same base of 9, but I can write them as a base of 3. So what do I have? 9 is 3 to the power 2, but I have x there. And then I have 3 to the power of 3. Lovely. So powers, equate them. What happens? Divide by 2. Lovely. So we're using the same principle to deal with so many questions. That's one question there, done again. I want to show you something again, because I don't want you to be scared of the questions. Oh, somebody's saying, fractions. Yes, fractions. 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 What do I do with this one? How do I escape this problem? Very simple. Look at the 9. The 9 can be written in terms of a 3. So I'll keep this. 1 over 3. Check this. 1 over 9. I can write it as 3 squared, right? So I'm going to do that. Oh, this is one of the laws, because 1 squared is 1 and 3 squared is 9. I hope that makes sense. So both of them now have the same fraction base. Therefore, x is equal to what? 2. Let's bring in more flavors. basic. We're going to do basic ones. We're not going to do very hectic ones. Okay, write as quickly as possible. I think I can write 16 as 2, right? Because it's a 2. So this is 1, and that's 2 to the power 4. Since the bases are now equal, I can equate the powers. Oh, not bad at all. Not bad at all. Not bad at all. We're just following the process of maths that we know. I have number 17 here. I'm going to stop at 18 and 19. Okay. Now, I noticed that that's a whole equation there, 2 to the power of that. But I am only going to do one thing to make my life easy. Write 35 as 2 to the power 5. Oh, sweet. Now, what do I know? Since the bases are the same, I can equate the powers. Do you remember this? Bracket and expansion. Oh, yeah. Where these have to go in and that go in. 2 times x is 2x. 2 times positive 1 is positive 2. Lovely. The positive 2 is multiplying. It's going to go over that side. And adding. It will go over that side and subtract. Oh, so my 2 is now multiplying. It will be 3 over 2. Easy peasy, just like eating pizzas. That's how math is. Math can be just so easy like that. Okay, just 2 more for fun. All right, 2 more just for fun. Just for fun. 2 to the power 3x minus 1 equals to, what is this? 2 to the power 6. Since the bases are now the same. Oh, lovely. 3x equals to, now this minus here would go over and become a positive 7. Now the 3 is multiplying, it will then divide. Okay, and we have the last one. The last one. Let's try this one. Oh, I did that one already. I wanted to do something like number 13. Okay, let's try one more. Look at this. So with maths, we can just be creating so many things, but the principles we are going to be doing will be the same. Isolate the variables. So I see that 4, and please, do you see that the 4 here is adding? So it's disturbing my life. I got to get rid of that 4 so I can keep my exponent. So if I move the 4, since it's adding, it will come here and subtract. 20 minus 4 is 16. Oh, I can write my 16 as 2 to the power 4. Since the bases are the same, I can equate the powers. Can we do more of this? Can we just have another slide of example? I promise you just 2 more and I will drop my boots. Or 3 more, sorry. 3 more. It's just interesting to do maths. Okay. So that's number 19. Okay, we need to finish now. I don't want it to be too long. Number 20. Let's look at this. Sorry, just want to change something here. 3 to the power 2x 24. Okay, let's see. So I want to keep my exponent on one side. So I've got to get rid of this negative 3 by reversing the operation. And it becomes a positive. Okay. So 3 to the power 2x, that's 27. Oh my days. 3 to the power 3. Beautiful. Since the bases are now the same, can you see that the aim is just to get the bases the same? The 2 is multiplying and then it divides. Was multiplying and then it divides. I hope this makes sense. Let me stop here. So we have 20 examples that we've looked at, various types of questions. So you need to write them down neatly. Go back. Every time you see a question, you go back to the examples to see, oh, what type of question is this? It must have been done in the examples, and you follow the steps again. I hope this lesson has been very, very helpful to you. Please pause, rewind, watch it as over and over again as many times as possible until you get all the principles right and you attack so many questions. All right, we did 20 already, right? Lovely. So doing this is not going to be so difficult for you. Everything has been done. So you just follow the process, walk through, and in our next lesson we'll be marking together. Whichever one you feel, difficult, I will deal with it in the next session. You can just drop me a comment to say, number 28 was hectic. Number 5, I'd love to read from you. Write down the ones in the comment section, what you felt was difficult. And I'm going to slow down when I'm dealing with them in my next session. So you have 20, how many questions is 28, 29, 30, 31, 32, 33, 34 questions. Beautiful questions. And please take a screenshot, all right, so that you can log off the video and write the questions down and get them sorted. I will see you in our next session when we answer questions. I hope you had fun like I did. All right, so I'll see you in session number 9. Goodbye, everybody. This is Crazy Physics.